Steve.
Okay, great. Good afternoon. We're here for 5 Minute Friday on the campus of Morehead University at the Space Science Center here on the anniversary of the Apollo 11 moon landing. Talking with Dr. Malphrus of the Science Center. Really excited to be here. Behind us right now is the lunar ice cube. And you've shared with us a little bit about the lunar ice cube. And if you would share for our listeners the exciting work happening here at the Space Center.
Okay, fantastic. Well, thank you, and I appreciate the opportunity to talk with your visitors. So the lunar ice cube mission, you can see the actual spacecraft, the size of the spacecraft behind us. It's a small satellite, and it's a NASA mission, but Morehead State University is the lead. There are a number of partners, the NASA Jet Propulsion Laboratory, the Goddard Space Flight Center, Busek Propulsion Company, but we're building a small satellite here at Morehead State's Space Flight Center to go to the moon and to orbit the moon to look for the distribution of water ice. And the idea is that we plan to return to the moon in 2024. Humans on the moon again in 2024 is NASA's goal. And before we get there, we would like to learn more about where to land and what resources are available. And water ice, it turns out, is an extraordinarily valuable resource. Astronauts need water, of course, to drink, but you can break down the water molecule and get oxygen and hydrogen, oxygen to breathe, and hydrogen as rocket fuel. So this little satellite is going to orbit the moon and use an infrared spectrometer to map the distribution of water ice, trying to figure out where the water ice is, ultimately where it came from and how much is there. And ultimately then the astronauts that go and live and work on the moon can utilize that resource. So the cool thing, though, is that it's going to be launched on the Space Launch System, which is NASA's new rocket. It'll be the largest, most powerful rocket in the history of the world when it flies in 2020. So more powerful even than Saturn V.
Just next year.
Just next year. Yeah.
The plan is for it to fly in 2020.
Exactly. NASA's building it up right now. And it's basically the replacement for the Saturn V. It's going to take the Orion capsule and astronauts back to the moon and on to other more interesting destinations, asteroids and ultimately Mars. The first time it flies in 2020, the mission is called Artemis 1, which is kind of cool because Artemis is the other sister actually of Apollo. And
Artemis 1.
Artemis 1,
okay.
Yeah, is the equivalent of Apollo. And Artemis is an interesting name because this time not all the astronauts are going to be male. They're going to be female astronauts that walk on the surface of the moon. Artemis was the sister of Apollo.
Nice.
So I think it was really a sort of
And
nice
we're
touch.
here today in the Space Science building while you have a Space Trek camp going on that's designed to attract young women to the space field.
Exactly. So Space Trek is a sort of engineering boot camp for young women. It's a 10-day camp, and young women come here in their sophomore and junior year of high school. And they spend 10 days on campus learning about electronics and communications and space systems engineering. They actually build a little satellite, a little miniature satellite, and they launch it on hot air balloons, weather balloons, and then they track it and pull down data and telemetry. So they basically complete a self-contained space mission in about 10 days.
Wow.
And that encourages them to go to the STEM fields. And we
Right here in Eastern Kentucky.
In Eastern Kentucky.
On the campus of Morehead University.
Right, at Morehead State, yes.
So back to Lunar Ice Cube for just a moment. Lunar Ice Cube is set to go up in space when? Next year?
In 2020, right.
In 2020.
End of 2020, it flies. So it gets a ride to Earth Escape on the Space Launch System, the new rocket. So, the cool thing is that it will be on the maiden voyage of the most powerful rocket ever built in the history of the world.
Wow.
And there are 13 small satellites like Lunar Ice Cube. Some are going to the moon, others are going to asteroids in different places.
Okay.
But they all get a ride on the rocket to...
and one of the satellites going is from right here in Kentucky.
It is built in Kentucky, yeah.
And it will be bringing back, or sending back, I guess, information that will be helping us prepare.
That's right.
Kentucky having a significant role in this prepare for the 2024 mission.
In terms of our return to the moon, human return to the moon, this is one of the critical precursor missions. So Kentucky indeed has a role in NASA's return to the moon, which is kind of neat on this sort of historic day and
Absolutely.
week for us.
That's right, on this day.
Yeah.
And so just a little bit about that mission in 2024. It's designed to be different than the Apollo 11 mission.
Right.
In that the hope is that we learn how humans could actually exist.
That's right. So
in space.
The difference is when we go back to the moon, we plan to stay. This time we want to build a lunar outpost want to learn how to live and work in a lunar environment. The ultimate goal, of course, is to get to Mars. But Mars is a long way away, and if something goes wrong on a 9-month journey, it could be a problem. Whereas the moon's 3.5 days away, so if something goes wrong, you can get back pretty
Just 3.5 days away.
Yeah, 350,000 kilometers.
I'll be back in a little bit, Mom.
Yeah, exactly. But it's a stepping stone to the outer reaches of the solar system and ultimately Mars. So it's an important stepping stone. So it really is an ideal place to do certain kinds of science, like radio astronomy. You can't do really very well from the Earth, but the far side of the moon is a phenomenal place to do it. And there are resources on the moon that are very rare on Earth, that are extraordinarily valuable resources, like helium-3. And so literally we'll mine the moon for those resources and utilize it for advancing our technology to explore the outer parts of the solar system.
So, Dr. Malphrus, I'd like to talk a little bit about kind of your trajectory in this field and kind of what inspired you. And I read an article recently where you talked about when you were 9 years old and seeing Saturn for the first time.
Yeah.
Last week I was in Colorado with my family, and my oldest son and I were out after dark using one of those apps where we could identify the different stars and the constellations. And he was certain one was a planet.
Yeah.
And sure enough, with that app, we were looking at Jupiter.
Yeah.
And just a little bit to the left was Saturn.
Okay, Saturn and then the moon. Yeah.
Yes.
Absolutely.
And so in that story, you shared, seeing Saturn for that first time at 9 years old.
Yeah.
That was the moment for you where you knew what you wanted to do.
I could trace it back to that exact moment. I remember looking through the small telescope in Savannah, Georgia, where my mother had taken me to this amateur astronomy night. And it was a cheesy little 8-inch telescope, but you could see, the rings of Saturn. And I thought, they will pay you to do this for a living. So it just put me on a trajectory to astrophysics and into aerospace engineering.
And certainly there was inspiration along the way for you to really tap into a richer vision for your own education. Yeah. What was some of that inspiration along the way?
So I had some phenomenal teachers throughout my high school and college careers and in my doctoral program. Certain books are inspiring. Television productions, KET. It has this incredible series on Moon and PBS right now.
Okay.
The
Apollo 11 landing, I'm sure.
The Apollo 11 landing was, I was 7 years old when the astronauts landed on the moon. So that was,
the stories were still rich at that time.
And the entire country was excited about space. I mean, we were doing something that was extraordinary and had never been done before. And really, we were pushing the envelope of the technology to the point where nobody really knew if we could pull it off. And it took, 40,000 people, the course of 7 years to be able to do it. So it was really an extraordinary effort.
So what do you say to students and parents today about their education and their vision for their future?
Yeah, well, I mean, the future is a different place. It's undiscovered country. It's different than certainly it is now. The technology that we have now is completely different in the future. The jobs that we're training students for now really won't exist by the end of their career. And so, it's really it's going to be a different world. And so what I would recommend students focus on are the fundamentals, math, science, STEM areas, because those are translatable. My background, for example, is in astrophysics, and now I do aerospace engineering, but all the math and the physics and technical writing capabilities, those are translatable skills. And so, focus on the STEM, the fundamental STEM areas in your background, and you can adapt to new careers.
A lot of times we hear that students aren't exposed to the variety of opportunities that they might have in the future. What's the importance of dreaming big to you when you think about students?
Well, I mean,
you were certainly dreaming big at 8.
Yeah. Well, they have to dream big. I mean, you have to dream and then work the dream. But if you don't run those theoretical models, you don't really know what's possible. So, I highly encourage dreaming. I have children myself, and I encourage them to, imagine the possibilities. Because if you don't, you really don't, you don't know what you can do.
Believe in those possibilities. Yeah, absolutely. So STEM education, you've
Mhm.
mentioned the importance of those kind of transferable skills or transferable knowledge
Right.
sets in mathematics, of
Yeah.
course, reading,
Yeah.
science. Share a little bit about just the importance of STEM education in Kentucky and nationally at this moment in
Yeah.
our nation's history.
Well, I think that's an excellent question. We're, certainly in a transition period in the U.S. because we are no longer technologically dominant in every area. And 10 years ago, we were. I mean, you could pick an area of technology and we dominated. That is no longer the case. We have a lot of rivals, and there's a lot of extraordinary technology being developed outside the U.S. And in some cases, we really sort of have to catch up. And so if we want to remain competitive, technologically and economically viable, we really have to produce more engineers, more scientists, more technicians. Not everybody is certainly cut out to be a scientist or an engineer, but that's okay because there are a lot of valuable careers that support those areas. And so these STEM careers lead to the technological development that will keep us economically viable for the future.
As we think about the future and we think about kind of what's happening here in Kentucky, here in Morehead, in the aerospace industry, I've learned being here today that the aerospace industry, manufacturing export is #1 in Kentucky.
Yes,
It's the #1 manufacturing export in Kentucky, and
That's
that's just happened in the last 4 years.
That's correct. Yeah.
So the question I posed to you was about talent
Mhm.
and the development of talent here in Kentucky. As that
Yeah.
industry grows, do you find that we're needing to import talent?
Yeah.
Are we educating young people to be part of that industry here in Kentucky? What does that look
Well,
like?
so that's an excellent question. And certainly that's our job here at the Space Science Center at Morehead State is to produce the workforce needed for the aerospace industry. And, 10 years ago, when we produced outstanding science graduates and engineering graduates, they would have to go to California or Colorado to get a job. And now there are opportunities in Kentucky. It's a $12 billion industry in the state. There are 19,000 aerospace jobs, aerospace-related jobs in the state of Kentucky. So now when our students graduate with a degree in space systems engineering, they don't necessarily have to go to California. Some still do, but we're keeping more and more of them. And then that attracts more companies because now they see that there's a workforce available. And so it's starting to snowball a little bit, and it's really only happened in the past 4 or 5 years. It's gotten to the point where Kentucky's an aerospace state. It's the most important industry in the state.
And it's not just about filling the jobs that are available today, but it's
Right.
about really being the visionaries, the dreamers, the creators of the jobs of the future.
That's exactly right. I mean, aerospace is growing at 20, 30, sometimes 40% a year, the industry in the state. And so it's just growing by leaps and bounds. And it's unclear if we can sustain that growth with the current workforce. So we definitely have to produce more graduates. And the thing is, the technologies that we're building today are the technologies of the future. So if you're not doing research, sorry, I'm going to call from space here.
Call from NASA.
That's right. If you're not doing the research and development, which is really primarily our job here at the Space Science Center, then you're not producing those technologies for the future. I mean, all technology has its origin in fundamental science. And so you have to do that fundamental research that leads to new technologies that then can become applied technologies that lead to marketable products. So you have to have that whole pipeline in place.
I read that the Cave Run Symphony Orchestra has coined you the spaceman in residence here at Morehead and in Eastern Kentucky, for that matter, in Kentucky.
Yes.
What, as you think about science now and in the future, our next giant leap, what excites you today?
Oh, there's so many things that we're on the verge of. Artificial intelligence is just an area that we're seeing incredible growth in. Microelectronics, microelectromechanical systems, MEMS devices. The miniaturization of electronics has really, combined with AI, really is going to create extraordinary doors. I mean, if you look at the spacecraft that we build, they're the size of a shoebox. And 10 years ago, you'd have had to build a spacecraft the size of a school bus to put that technology in. And so everything's gotten smaller and certainly more capable at the same time. And so we're pushing the envelope of these technologies. Faster computer processors, more capable microcontrollers, MEMS devices, coupled with AI and new materials and material sciences. All of these technologies are really making advances sort of in the background, and you won't see these products for a few years, but it's going to be a very interesting and different place in the next 10 years.
You have a lot of hope for the future.
I do have a lot of hope for the future, and it's primarily because of the outstanding talent that we're producing, and much of it here in Kentucky.
This vision for you started here in Eastern Kentucky, started about 10 years ago?
Correct, yes.
Okay, so it's been about 10 years in the making.
Right.
And over the last 4 to 5,
Yeah.
aerospace, as we mentioned, has become the number one manufacturing export. So that's
That's
quite
right.
a realization of a vision.
Well, I have to admit, it's certainly, it maybe is to some extent coincidental. Sometimes you get lucky. We happen to be at the right place at the right time with the right technology. There are so many people that are responsible for the evolution of the aerospace industry in the state. And we have a small contribution to the space segment of that aerospace industry. So, the workforce development a little bit and the R&D in the space side. But yeah, we had a vision 10 years ago to build a tech hub, an aerospace tech hub in Kentucky. People like Chris Kimmel with the Kentucky Science and Technology Corporation envisioned that Kentucky could be an aerospace state. That was 10 or 12 years ago. People kind of laughed at it. And we've always wanted to have a high-tech hub here in Eastern Kentucky. Now we're starting to have companies come in, spinning off companies from universities. So it's really starting to produce a sort of critical mass of aerospace companies that are really allowing us to grow.
Yeah. Well, at the Pritchard Committee, we like to believe that big things are possible when we all come together with a collective effort toward a shared vision. And you've certainly proved that that is possible in your world, and you've brought that here to Eastern Kentucky, and we are incredibly grateful for your work and the opportunity to talk to you today. To hear about this work, to be inspired by the young people we see present, the lunar ice cube model that we know will be going up in space next year, knowing that Kentuckians are a big part of that.
Absolutely. And sometimes big ideas come in small packages.
No doubt, no doubt. I completely agree. Yes. So, Dr. Malphrus, thank you so much for this interview today. Again, on the anniversary of the Apollo 11 moon landing, and looking forward to a moon landing in our near future. The sister of Apollo, Artemis
Yes,
1.
That is correct.
So just 6 years,
That's right.
6 years around the corner. So we'll look forward to that, and maybe we'll come back and talk to you again as we get closer. We'd love to hear how things go with Lunar Ice Cube.
It'd be my pleasure.
Thank you so much.
Thank you. Thanks for having me.
Thank you.